Hello friends, in this discussion I want us to look at dimension analysis. We are going to cover this question which says that the Stokes formula gives an expression for the viscous force acting on a small sphere moving through a homogeneous viscous fluid. Now here we have that the viscous force F acting on the sphere depends on the viscosity of the fluid given in that symbol, the radius of the sphere which is r in the viscosity velocity of the sphere. Now with this derive the Stokes formula using dimension analysis. So before we look at the solution to this problem, let us identify some parts, which is the viscous force, the viscosity, and also the homogeneous viscous fluid. Now let us start with viscosity of the fluid. We try to explain this. So viscosity of the fluid simply talks about the ability of a fluid, which can be a liquid or a gas, to simply resist flow. So we have high viscous fluids and lower viscous fluid. So in a case where a liquid has high viscosity, it means that it will have higher, like it will resist the flow more than the ones with the lower viscosity. Then for the homogeneous viscous fluid, this is what we're talking about, uh, the maintenance of the viscosity regardless of the position and also the time. And then the viscosity force, this is simply a force that opposes an object to simply move. Now the viscosity is simply given as the Pascal second. Those are the units, which can be abbreviated as par, then a dot, then second, s, like that, which is also known as a poise. So the unit is also known as a poise with a symbol of a p, like that. Now 1 Pascal second, which is a unit for the viscosity, is the same as or is equivalent to 1 Newton second multiplied by meter to the power -2, like that. So Newton simply represents the unit for the force, so it will be the same as 1 kg meter. So we have 1 kg meter per second squared, which is meter s squared, power -2, then multiplied by the other units that we have there. So this, upon simplifying, to give us kg, that would be m to the power -1, then s also to the power -1. So this is what we have. Now let us simply look at what we have. Now the force there, we have that it is dependent on the viscosity, so to be forced to vary directly with the viscosity of the liquid, of the fluid, sorry, and multiplied by the radius, multiplied by the velocity. So now what we do is to change this to an equal sign. I'm going to introduce a constant of variation, which is a k there, multiplied by what we have on the right hand side. Now the next thing is we're going to assign exponents for all the quantities that are on the left. On the right, so we're going to have the viscosity to the power a, the radius to the power b, the velocity to the power c. Then what we're now going to do is we're going to solve this equation dimensionally. So we're going to use dimension analysis to simply solve this given equation. Now since we know that dimension analysis has constants to be dimensionless, so it will mean that k will have no dimensions, or in short, it will not be considered as we start solving our equation. So we're going to have the dimensions for F, which are force, which is like that. Then our constant will be ignored. Then the viscosity is will be gotten from the units that we have. So this is m for kgs, then L to the power -1, then T to the power -1. Now remember that we have to the power A there. Then come to the radius. Radius is length, so to be L to the power B. Then velocity is Lt to the power -1. Then this is the power C. So write the left hand side for now, the way it is. So the left hand side will be maintained for now. So we're going to have m L T to the power -2. Then on the right, we can distribute the a with what is inside the brackets there. So we have m to the power a, L to the power negative a, t to the power negative a. Then we go to the other part also. This is just L to the power b. Then the other part is L to the power c, then t to the power negative 2c. Negative c, sorry. Now the left to be maintained for now. Then we go to the right. So to the right, we're going to simply use exponents. So we'll multiply. If the bases are multiplying, you add the power. So we're going to have L to the power negative a, then plus b, then plus c, since the bases are the same there. For L, then for t, you have negative a minus c, like that. Now, since the bases are equal for both sides, so now we're going to have a to be equals to 1, that is for mass. Then for L to be negative a plus b plus c to be equal to 1. And for t, which is time, to be negative a minus c to be equal to what? To negative 2. Now a is already 1, so we're going to substitute in the third equation. So it will be negative 1 minus c, which is simply equals to negative 2. So this will be negative c, which is equals to negative 2 plus 1, giving us negative c to be equals to negative 1, meaning that our c will be equals to 1. Then we're going to substitute c and a in the second equation. So it will be negative 1 plus b, then plus 1. This is simply equal to 1. Now when we add negative 1 and 1, we get a 0, so that our b is simply equals to 1. So we have a, b, and c all to be equals to 1. So the values for a, b, and c are all at 1. So what we're going to now do next is we're going to substitute these values for a, b, and c in our equation. So we're going to substitute them in our equation. So our equation is given as the force. So substitute these ones in our equation. So this is our equation there. So our equation is given as F, the force, which is equal to the constant multiplied by the viscosity to the power A, then the radius to the power B, and the velocity to the power C. Now we know what A, B, and C are, so it will be F equals to K, then the viscosity to the power 1, that will just be like that, then R and V like that. Now according to experimentation, since K cannot be obtained by dimension analysis, so that if we do experimentation, we will have that the value of K is simply equals to what? To 6 pi. So by use of experiments, we have that the value of K is simply equals to 6 pi. So where there's K in this equation, we simply substitute with the 6 pi. So that's what we'll have. So we'll have our F. So this will therefore mean that our F, the force, will be equals to 6 pi, the viscosity multiplied by the radius, and the velocity. So this sort of is our